Hey guys, so we're going to get started on lesson 5.4. Let me present my screen and we'll get started. All right, so in lesson 5.4, we're going to be talking about isosceles and equilateral triangles, some theorems and corollaries related to those types of triangles. Okay, so the first theorem we have is the base angles theorem, which says if two sides of a triangle are congruent, then the angles opposite them are congruent. So let's start with the hypothesis part. If two sides of a triangle are congruent, well, then that would make it an isosceles triangle, which you can see here. Triangle ABC is isosceles because we have side AB congruent to side AC. So when we see an isosceles triangle, now we know this theorem that says the angles opposite the congruent sides are congruent. So what I mean by that, ignore that little scratch, is the angle opposite this side AC, so that would be this angle here, angle B, and the angle opposite this side here, so draw an arrow, opposite this angle here, angle C, those two angles are congruent. So angle B is going to be congruent to angle C, all right? So again, if your two sides are congruent, now you know your base angles are congruent, as you can see is written here. Angle B is congruent to angle C, all right? All right, the next theorem that we have is the converse of the base angles theorem. So basically the opposite of what we just said. All right, switch the hypothesis and the conclusion. So if the base angles are congruent, then the sides opposite those angles are congruent. All right, so if angle B is congruent to angle C, that would mean that side AC is congruent to side AB. And then once we know that those sides are congruent, we know it's an isosceles triangle. So there's my conclusion there. Could you go into the other room? Go into the other room. I ask for quiet. They don't understand that concept. Okay. Next, we have a corollary to the base angles theorem. Okay, it says if a triangle is equilateral, then it is equiangular. Okay, so again, what does equilateral mean? It means that all the sides are congruent. So when you have a triangle with all the sides congruent, if it's equilateral, that means it's also going to be equiangular. All right, so we have here, and one other thing that we should always know about an equiangular triangle, since all three angles of a triangle add up to 180, and we said all three angles are going to be congruent, we can divide by 3 and get that each angle here is 60 degrees. So that's just kind of a fact that you should know, but you also know how to figure it out, okay? And then the converse of that theorem is true as well, that or corollary, excuse me, that if all three angles are congruent, if it's equiangular, then it's also going to be equilateral. All right. Let's move on to the next page. All right, so we have some practice problems that we're going to go through together. In exercises 1 through 4, it says complete the statement, state which theorem you used. Okay, so it says if side NJ, so let's locate NJ with, I gotta get my pen, with a tick mark. If NJ is congruent to NM, then which angles are congruent? So visualize just this large, if I can trace it, triangle. Ignore the segments that are in the middle. And you can always, if it's helpful, come down here and just draw that triangle, J, M, N, right? If this side is congruent to this, then based on the isosceles triangle theorem, we know that the base angles are congruent. So we can say that angle M is congruent to angle J, all right? And it says state which theorem you use. So that is the base angles theorem. Base angles theorem. Okay. The next one says if LM, so that's this side here, is congruent to LN, this side here, So again, try to get your eyes to just focus on this triangle. And if you want to redraw it on its own, you can. So if those two sides are congruent, which angles are congruent, you'd have angle M is congruent to this angle here. Be careful, you can't just call that angle N because N is part of four different angles, right? This angle, second, third, or the entire thing fourth. So to name this angle, use 3 letters, L, N, M, or M, N, L. You could go backwards, okay? And that is, again, the base angles theorem. All right, let's try the next one. The next one says if angle NKM, so go from N to K to M, so we just traced over this angle here. If that angle is congruent to NMK, so that's this angle here, then which sides are congruent? So again, you want to focus your eyes on this triangle. Wish it was easier for me to trace. Go straight. Okay, that triangle there. Remember, the sides opposite the base angles are congruent. So I can say that side KN is congruent to segment NM. And that's the converse of the base angles theorem. Converse of base angles theorem. All right, and last one from this section. It says that if angle LJN, so LJN, that's this angle here, is congruent to angle LNJ, so that's this angle here, right? So again, focus your eyes on this triangle, right? So which sides are congruent? LN is congruent to the side across from that angle, which is JL. And that again is the converse of base angles theorem. All right. So that's the first 4 problems for today. Oh, these were not on the other page in my packet, which was concerning to me, but that's okay. All right, so we have a few more problems to work through. It says in exercises 1 and 2, find the value of x. All right, so looking at this triangle, I see that I have an isosceles triangle. This side is congruent to this side. So which angles are your base angles? Which angles are congruent? This angle is congruent to that angle. If this angle is labeled x, I can label this one as well. Okay, now what do the 3 angles of a triangle add up to? The 3 angles add up to 180. So you can write x plus 130 equals 180. Combine like terms to get 2x plus 130 equals 180. Subtract 130 from both sides. You're going to have 2x equals 50. Divide both sides by 2 and you get x equals 25. And the question just says find the value of x, which we did, so we're done. All right, and the next problem, I again see that I have base angles congruent. So based on the converse of the base angles theorem, I know that this side I can mark congruent to this side. And if the sides are congruent, that means they're equal. So I can set 24 equal to 3 times the quantity x plus 2. And now it's just an algebra problem. You could divide both sides by 3 to start or distribute the 3, and it's up to you. I'm going to divide both sides by 3. So I have 8 is equal to x plus 2. And then I'm going to subtract 2 from both sides, and that's going to give me x is equal to 6. All right, moving right along. So in exercises 3 and 4, it says find the values of x and y. So let's kind of look at the diagram first and see what we can figure out because there's a lot going on in diagrams. All right, first I see that this angle is congruent to this angle, which is congruent to this angle. So that makes the entire triangle, what kind of a triangle? Equiangular, right? All three angles are congruent, it's equiangular. And if it's equiangular, that means it's also equilateral. So that means that this side is congruent to this side, which is congruent to this side here. So if this side is 46, that means this side is 46. And it also means that this entire side here is 46 because all three sides are congruent. And that's going to help me solve for y, right? So now I know that the length of this segment here is 16 plus the length of this segment here, y, equals 46. That's using the segment addition postulate. I can subtract 16 from both sides, and I'm left with y is equal to 30. All right, I still have to solve for x. Okay, x is this angle right here. Let's use the fact that we said that it is equiangular. If it's equiangular, if all three angles of this large triangle are congruent, what's the measure of each angle? It has to be 60 degrees. This angle is 60, this angle is 60, and this entire angle is 60 as well. Okay, x is just this portion, right? This part of the angle. All right, let's use the fact that we know all three angles of this triangle. Oh, no, I don't. Sorry. Let me erase that 60 down there because it's confused me for a second. We do know that this entire angle is 60, okay? But let's figure out what just this piece is here, right? If we know that this angle is 80 and this angle is 60, and I'm focusing in on this medium-sized triangle, the three angles have to add up to 180. So if you take 180 and subtract 80, that leaves you with 100 degrees. Then subtract 60, that leaves you with 40 degrees. Now we said that this entire angle is 60, right? If this portion is 40, what is this portion here? That's your x. So it's going to be x plus 40 equals 60. Subtract 40 from both sides, and x equals 20. All right, let's move on to number 4. I'm just going to erase all that just so it's less to look at, less of a distraction on the paper for us. Okay, so for number 4, I'm going to start by looking at this small triangle. I see that all three angles are congruent. What does that tell you? It tells you that it is equiangular. Each angle is 60 degrees. It also tells you that it's equilateral. All three sides are congruent. Okay, so I could label it 5y, 5y, 5y if I wanted. But also notice, let me erase that for a second, this side here is marked with a tick mark, and this side here is also marked with a tick mark. So this side is 20. But we said that this is equal to this side because this little triangle is equilateral. So if all three sides are congruent, now I know that I can set 5y equal to 20, divide both sides by 5, and you get y is equal to 4. All right, so let me erase some of that so I can kind of look back at the diagram again. All right, so if this is an isosceles triangle, and I know that base angles are congruent, the angle across from this side, which is labeled with an X, is congruent to this side here, or this, angle there. They're both going to be congruent to each other, all right? But I don't know any of the angle measurements, or maybe I do. Let's go back to the fact that we know that each of these angles is 60. What I want you to focus on is this angle right here. What's the relationship between this 60-degree angle and this angle right next door? They're a linear pair, right? They're next to each other, they're adjacent, and they add up to 180 degrees because you have that straight line there. So they're supplementary and adjacent, that makes them a linear pair. So if this angle is 60, this angle has to be 120 because they have to form that straight line and add up to 180 degrees, okay? So I'll keep erasing because the diagram's kind of small to work with. This angle is 120, 120. Oh, that doesn't look like 120. I think I'm just gonna write it outside and then point. This angle right here is 120. Now, these two angles are congruent to each other, so I can label them both X and X, and the three angles have to add up to 180. So 120 plus x equals 180. Subtract 120 from both sides and combine like terms. So you have 2x is equal to 60. Divide both sides by 2, and x is equal to 30. Okay. Any questions there? All right, I think that might be all. Give me 1 second just to take a quick look at what I have listed down. Yeah, we'll talk about number 5. Not going to write it all out, but we'll just talk about it quickly. All right, so do you all see that this triangle here, triangle DCE, is an isosceles triangle, right? Side congruent to side. So I know both base angles have to be 70 degrees. If the 3 angles of a triangle add up to 180, if I add 70 plus 70, that gets me to 140, which means this angle has to be 40 degrees. What do you know about vertical angles? Vertical angles are congruent, so this angle also has to be 40 degrees. And then the 3 angles of a triangle have to add up to 180. So if you take 180 and subtract 70, that leaves you with 110. Take 110, subtract 40, that leaves you with 70. So the question here says, explain why triangle ABC is isosceles. Well, is it? I have my base angles are congruent. So does that mean that my sides opposite those angles are congruent? Therefore, it's an isosceles triangle. Okay, so I talked about all the steps. I didn't write them out. You can go back and write them out. Listen to what I said again and write them out as steps if you want. Just make sure you understand the logic behind that. All right. And the last one, I'll just do a quick sketch. That way this whole page is done. It's always nice to have the whole page completed. Can an isosceles triangle be an obtuse triangle? Well, what makes a triangle obtuse? It has to have at least one obtuse angle. And what makes a triangle isosceles? It has to have 2 congruent sides and the base angles have to be congruent. So again, I'm just sketching. This is not drawn to scale at all. But if I draw a really terrible isosceles triangle, let's pretend that this is congruent to this. And let's say that these are small little 10-degree base angles. Well, again, if all 3 angles have to add up to 180, 180 minus 10, 170, minus another 10 is 160. And again, I know it's not drawn to scale. Is that an obtuse triangle? Yeah, okay, it has one obtuse angle and it's also isosceles. So can an isosceles triangle be an obtuse triangle? Absolutely. Right. Okay, so that is it for this lesson here. Let me just erase that. Stop presenting, and I'll see you guys back here for lesson 5.5. Bye.